Hi everybody, my name is Josh and thank you for joining me in this video today. I plan to walk you through one of the Python programming challenges I recently took at pythonchallenge.com. This is my way of trying to learn the Python 3 programming language. I've been using programming off and on in my career. I'm not a professional programmer, but I do use C# and Perl to solve some day-to-day problems. I've seen that Python seems to be becoming more and more prevalent and seems becoming an industry standard. So I decided to try and learn it. And I thought, what better way to learn it than to try and do some challenges for fun, just to try and learn by doing. There are 33 levels on this site. I don't know if I'll necessarily get to level 33. I've been through 16 of them so far. What I was going to walk you through today was the last one that I completed, level 16, just because I thought it was really neat. And I used some stuff in there that I haven't used before. So without further ado, I'll go right over to the challenge. So what we see on the challenge page is an image that just appears to be static. Just a quick note that if you do visit this URL, you will be prompted for a name and password that you'll need to obtain from completing one of the previous challenges. I won't disclose that here just in case you want to try that on your own, but just a heads up on that. So again, the image itself appears to be static. Looking at the source of the page doesn't really get you a whole lot. It basically repeats the title. I can talk. Let me get this straight, and just a link to the GIF that's here. So when I first looked at this image, I thought the thing that stuck out to me were these sort of purple or bluish lines on or segments on each one of these lines in the image. So I thought I had to do something with that. So jumping over to our code, and if I can just get there, boo, boo, boo. Where are we? There we go. We have our code here, and we basically need to read this file and look at those anchors, I'm going to call them. And we need to be able to find them. So what I did to try and find these, and let me see if I can just open the image. I'll open that in Photoshop. And what I ended up doing was I opened it in Photoshop just because I use Photoshop. I'm sure if you have another image editor out there, you can use that. But I zoomed in on it, and what I cared about was line by line trying to find each one of these segments. So you can see they start off with, if I click on one of these white bits, you have a section that has color codes that are RGB 251, and then it goes to these bits in the center that are 255, 0, and 255. So what I wanted to do was to read the image line by line and find these anchors and align them, because I figured that's what is important here, was to align those anchors but also drag the entire line of the image along with it to see if we could get something out of it. So when you see the color codes in my code, that's how I got them, is I opened it in Photoshop and got them from there. So opening my code, let's see, you can see it's not a very long script, but I did use some things that I had to look up. So, and I don't think I actually used string in here. As I was solving these challenges, I ended up just creating a Python template file, and which had the same headers, the shebang line and stuff in there. just so I wouldn't have to type the same thing over and over again and just delete it out of it. But we did need to use the pillow library, which, if you don't know what that is, you can just type in Python pillow library, and that brings you to a page that describes the Python pillow library. But basically, it is a way of manipulating images with Python. So I needed to import the image module, which lets us read a file and then write a file out along with a bunch of other functions. And then also I needed to use the image chops module, which this is the important bit and one that I wasn't familiar with. I had to look it up. This is the bit that once we find that, it allows us to chop the image up line by line and then find that pixel, that pattern that we care about to try and shift it around. So we imported our string, which again I don't think I actually used here. We imported the image library from Pill, and then we also imported image chops from Pill. We then opened our image file, mozart.gif, into a new image object, and then I stored in a size variable the width and height of that image, and then was able to then use that information to just make a new image. So instead of overrunning our current image, I created a new image, and that's where I plan to actually save the changes. So I just used the image library to make a new image with RGB color, and using the same size as our previous image, and set it to a black background. So if I just run this, and I can just say input, and just have it stop, and instead of printing the image out, I'll say new im.show, and save that, and we'll go ahead and run it. And what we get is just the black image here. And then if I just kill this, we'll just jump out of it. So what we needed to do within the actual image file itself, mozart.gif, was to read it line by line and figure out a way of chopping that line up into bit parts that we could process to try and find. So I created just a standard for loop, and just set it to for each y within the range, based on 0 to our height. So the height of the image, we're going to loop through each line. I created a new variable called crop box, which is what we're going to use in our image chops module. And within that, if we just look for crop, and am I on the right one? Crop box. Maybe it's here. Yeah, crop. So image crop says it returns a rectangular region from the image, and it takes a 4-argument sort of tuple, or it takes a it takes a tuple as its argument. So it takes the left, upper, right, and lower positioning of whatever coordinate you give it, and then it returns an image object to you. So I set it to 0. I set it to as our left. So we're starting from the top left. I give it our y, which is the first run through is 0. I give it the width, and then I give it our lower of our y, +1, since we're 0 based. I then run that through our crop and get a new row back. So from here, if I just take this and I'm just putting a stop here, and then if I say row.show and save that and run it, we now get the actual row, which is kind of hard to see, but it returned the first row or line of that image. And I'll go ahead and jump out of this again. So after that, and I'm going to remove this row that show up here because I don't need, or image that show, I don't need that. I then set up some other variables here. So I wanted to know the current row size, which is the row width or row height, based on the current size of the row that we got back. I then set up some flags for a found and a found at, because we're going to loop through that row and try and find those specific colors that we looked at in Photoshop. So I said I made another loop, and I just named it for each pix, so for each pixel in range, starting from 0 to a row width. I set up an RGB variable and set it to be row.convert. I also needed to look this one up too. I didn't have this initially, and I was getting some errors. But I needed to convert the row to an RGB because the GIF it had to do with it was a GIF image, not like a PNG or a TIFF. I needed to convert it to RGB. So once I had that object set, row converted to an RGB image, then I could use getPixel to actually get a specific pixel out of that line. And then I saved that into its constituent parts of RGB. So then it was fairly easy then to then say, okay, if R is 255, G is 0, and B is 255, which was our sort of white value, and found is 1, then we know we found the first part of this thing. Yep, and just rereading that, so sorry, yep, and found is 1. Then we can go into it, we set our found, we turn our found to 0, indicating in this that we found it. I record where I found it, the position where I found it. And now I can use image chops, which I thought was really cool. This is where we can actually shift that line over in our new image. So image chops, we need to use an offset. So it accepts our current row, and we need to know where we give it a position to start. So we have our found at less 1 since we're 0 based, but we actually need to subtract that out. And if you look it up, so let me see if it's on this page, offset. Yeah, offset. Does I have a page in here? No. Thought it had more of a description there, but it just takes an offset and a Y offset, and shifts back. It returns back the offset version of that image. So we took our row, we took our found at, and then I gave it a negative value here, basically because I'm subtracting where we found it to shift that back, and then I'm storing that in our new image, and we're going to build this new image line by line. So I saved that as a new image object, and then under this we're going to paste that onto our image. So our new image that we created on top, we're pasting this in line by line. So we're going to paste it onto using our new image 2 object, and we're saying starting at 0, paste in our current Y, our positioning based on our current Y. So basically, line by line, we're going to march down through this image, and then we increment our Y value, our current Y plus 1, and then we do the whole thing again. This actually takes a minute. I'm sure this is probably not the most efficient way to do this, but it does work. So if I go ahead and just run this, we'll be able to see this. And I made changes here, so I'll need to save it. We run this, and boom, we have a new image. Okay, sorry about that. I accidentally stopped the recording while I was trying to open this image. So what I was trying to illustrate is, again, is this is our starting point. So we have a scrambled image with these anchor points in it. And then we have our answer here, where we took the anchors and we left align them. Fortunately, it worked out to be a left alignment, and I didn't, right align it or something, and that would have caused more of a problem just to sort of figure that out. And I hope you enjoyed this challenge. I know I did. I learned a lot going through it, just looking up how to use the Python pillow library. It's not something that I was normally used to using, so it was fun to kind of look it up and see how to figure out how to use it. The one thing I know that gave me a problem initially was the line here for the RGB conversion. Again, that's just not something I'm used to using. I think in my day-to-day programming, I'm used to this. It's a file manipulation, text file manipulation, reading files, parsing them, that sort of thing. So image file manipulation is just something new. So some of the other challenges use PNGs, and I didn't necessarily need to use this line, so it was giving me problems parsing this until I figured out that's what I needed to do for a GIF file. Again, learned a lot. I hope you enjoyed this. I think I may go back and try and make videos for the first 15 solves that I did. And as I go through them, assuming I do get further solves, 17 onward to 33, I'll try and document those as well. So again, hope you enjoyed the video, and I'll see you next time. Bye.